In this video, we are looking at the supplemental notes page for lesson 7.3. And on this page, we're going to talk about how do you actually prove that a quadrilateral that's on a coordinate plane is a parallelogram. Now, there's different ways you can actually show that a quadrilateral is a parallelogram. We're going to choose one way that most people think tends to be the easiest and the quickest way, and we're just going to stick with that. So we only have to remember one method for showing that a quadrilateral is a parallelogram. So when proving a quadrilateral is a parallelogram, check to see if the midpoint of the diagonals are the same. If the midpoints of the diagonals are the same, what that tells us is that the diagonals bisect each other. And we know when diagonals bisect each other, then the quadrilateral is a parallelogram. And so if we check that and they are the same, the quadrilateral is a parallelogram. So we're going to be using our midpoint formula. This is coming back from semester 1. And we have a quadrilateral here on our graph, and they give us some points of these vertices. And so what we're going to do is we're going to focus in on the diagonals. So I'll do this in a different color. Here's one diagonal of the quadrilateral, and here is the other. Okay. Now it looks like those diagonals bisect each other. It looks like they intersect at the same point here, where in that point looks like it's in the middle, but we don't know for sure. We have to show mathematically using our midpoint formula. And so first, let's find the midpoint of our orange segment, AC. Okay, so we're going to find the midpoint of AC. Okay, that requires us to use the x and y coordinates of A and the x and y coordinates of C. So we're going to plug our values into our midpoint formula. So x1 plus x2, that would be -2 plus 2. And then we're going to divide that by 2. This will give us the x coordinate of our midpoint. To get our y coordinate, we need to do y1 plus y2. So 3 plus -1. And then divide that by 2. So let's go ahead and do this math and see what is the midpoint of line segment AC. -2 plus 2 is 0, and 0 divided by 2 is still 0. 3 plus -1 is 2, and 2 divided by 2 is 1. So we found the midpoint of our orange diagonal. Now we're going to go ahead and find the midpoint of our blue diagonal, so DB. This time I need to use the x and y coordinates of B and the x and y coordinates of D. Again, I'm going to plug these x and y values into my midpoint formula. So x1 plus x2 gives me 3 plus -3 divided by 2. And then y1 plus y2 gives me 2 plus 0, and then I divide that by 2. 3 plus -3 is 0, and 0 divided by 2 is 0. 2 plus 0 is 2, and 2 divided by 2 is 1. These two diagonals have the same midpoint. That means the diagonals bisect each other. So we know quadrilateral ABCD is a parallelogram, and the reason for that is the diagonals bisect each other because we've shown that their midpoints are the same. Okay. Let's go ahead and in this next example, we're going to determine whether this quadrilateral is a parallelogram or not. I'm going to start by graphing my figure. Go ahead and pause the video or do this with me. So here's my quadrilateral. I'm already looking at this. It definitely doesn't look like a parallelogram. So I have a hunch that we're going to say it's not a parallelogram, but we still have to show using our calculations that it's not. So again, we're going to go ahead and focus in on the diagonals. We want to figure out, do the diagonals bisect each other? Okay. So let's start by finding the midpoint of diagonal TR. I'm going to use the x and y coordinates of point R and point T in my midpoint formula. You could go ahead and pause the video and try this and then check your work with me. That might be a good strategy. x1 plus x2 divided by 2. y1 plus y2 divided by 2. 2 plus negative 5 is 3, and I'll keep it as 3 halves as a fraction. 2 plus 2 is 4. 4 divided by 2 is 2. So the point 3 halves 2 is the midpoint. Oops, I'm sorry. I made a little mistake here. 2 plus negative 5 is negative 3. I apologize. So the midpoint of diagonal TR is negative 3 halves positive 2. We want to just double check and make sure that is not the midpoint of diagonal SQ. So let's find the midpoint of SQ. x1 plus x2 divided by 2. y1 plus y2 divided by 2. Negative 3 plus negative 1 is negative 4. Negative 4 divided by 2 is negative 2. Negative 6 plus 2 is negative 4. And I'm thinking I made a mistake somewhere. I'm trying to... there it is. Negative 6, y2 is 6. I was going a little fast there. Negative 6 plus 6 is 0, and 0 divided by 2 is still 0. Okay. So the midpoint of diagonal SQ is negative 2, 0. These are not the same. And so what this tells us is the diagonals do not bisect each other. So QRST is not a parallelogram because the diagonals do not bisect each other.